So what's the
Okay,
question?
so here's an example. I would like to find
21 on.
gradient vector. So this is 14.3, number 21. And really, I just pulled an example out of someplace. So I want to find the gradient vector for f at this point minus 1, 3. And my function is like 1 over the radius squared. Cool? Alright. Do you guys have an idea about what this thing should look like?
Maybe like. Yeah. Take a 1 over x squared and spin it around.
Yeah. Yeah, take 1 over x squared and... Yeah, for sure.
Would it just infinitely flatten out at that point at 0?
Yeah,
Okay.
so this will kind of run out, right, and tend in all directions towards the xy plane, right? Okay, so, gradient vectors on this should be interesting, right?
Always towards the origin.
Yeah, they should really point pretty much straight at 0, right? At least I think that's what they should do. So let me see. So can we calculate the gradient of f first without evaluating at a point?
Yeah.
C.
Okay,
One
should be
over
2
x.
things, right?
Yeah.
Okay, you guys remember the...
Negative 1 over x cubed,
Ooh.
right?
We still need chain for this, don't we?
Uh-huh.
Do we, what?
Yeah, still need the chain rule for this one.
So it's
So-
going to be natural log of.
No, you're not integrating, you're
Yeah.
differentiating.
Can you think of it as 1 over r squared?
Oh, right, yeah.
So it'd be the L.
So it would be x squared plus y squared to the negative.
Oh, okay,
Negative.
okay,
Negative.
Uh-huh, so it's x squared plus y squared, all to
Yeah.
the negative first.
2x over, negative 2x over x cubed.
Negative 2x over x squared plus y squared
Squared.
squared.
It's negative 1 minus 1.
Yeah, so I'm thinking, right, that this guy here is x squared plus y squared to the negative 1 power. So I took the negative 1 power down. I did this stuff to the 1 lower power, right? That's this stuff squared. And the negatives for my power, and then the 2x, where the hell did that thing come from?
It's from the
So you
derivative
see-
from the inside because y is a constant.
Yeah.
Perfect. And so the y information, what do you
It's the
get?
same except negative 2y over. That's
Perfect. You get negative 2y over x squared plus y squared squared.
Why does it come out negative?
because the negative 1 comes
Negative
to
You're
one.
pulling down a negative x.
Then you need to pull down this negative power, and then that stuff, the 1 lower power. Okay. Ah. And then what do you notice about this vector?
We'll have negative outputs.
So if I put in an x and a y, right,
Uh-huh.
I'm going to get the same number on the bottom, right? And then I'm going to get negative twice the x component and negative twice the y component. So where's that going to point?
In the opposite direction of.
It's going to point in the opposite direction that the thing you fed it pointed, right?
Okay.
So the thing I fed it was pointed from 0 to the point I was going to. The other thing should point from there back to the origin. But the length, of course, is all dorked here. Right, it's some weird function of the radius and 2. But it at least points at 0. So can we get the thing they asked for? They wanted gradient of f evaluated at minus 1, 3.
That one's 150 and then the other one's 6 over 100. So 350.
2 over.
Let's see, so I got positive 2 over,
X. So negative 1 squared is 1, 3 squared is 9, 1 plus 9 is 10, 10 squared is 100.
perfect, cool. And the other one is
Negative
negative 6 over
that same thing.
also 1 plus 9 all squared. So you get 1 over 50 comma,
Three
Negative
over
3
50.
over 50.
negative 3 over 50. Okay, so there's that weird length, right? That 1/50th is kind of bizarre. Right.
That's
Height.
just the slopes at this point.
Yeah, that's really telling you kind of how fast you're going up or down, right? And that makes sense a little bit when I think about, okay, if here's x and y, negative 1, 3 is back 1, right 3. So that thing's, oops, someplace on the back side of my funnel. Let me adjust. Okay, adjusted. Now I'm going 1 over 3 out, so that should be someplace here on the front. And the direction steepest uphill from that should be back behind it, pointed straight at the origin. That thing is in fact pointed straight at the origin from there. You guys cool? That sort of makes sense? Okay. Other thing? Questions, thing?